So, welcome to Modularity Part 2. Can you guys please give me a thumbs up if you can hear me, if the sound quality is good? So, is the sound all right? Okay, let me see what I can do. Let me see. And is this any better? And how about now? All right. Thank you for the feedback. There's been some changes to the technology stack for the webinar, so there's been some tiny hiccups, but we're ready to go. So all systems check, and let's get it over with. Or get it over with, that doesn't sound very positive. Let's get it started. Let's get it on. UFC is coming up this weekend, and I'm very excited. So anyway, modularity. So you guys may have attended the first one, and this is part 2. So if you have a look at the slides, what we're looking at right now is decision deferment. So I'll recap slightly what we did the first time, and then we'll get into the learning goals of today's session. So first of all, part 1, we discussed these four learning goals. The first of which is to know a simple one-sentence definition of what a module is. So I'll just repeat the definition that we used, which is a composable unit. A module is a composable unit with a contract interface. So composable meaning you can combine modules together to create something larger than the module itself, and an interface contract in the case of modules means, well, modules can connect to one another. There's connecting pieces. Remember last time I talked about an example of Lego pieces. Lego blocks are modular. You can connect them, and there's a certain expectation about the nibbles, and then once everything follows those rules, you can have all kinds of variations, and they'll still be able to interface. So the next learning goal that we covered last time was to know who the godfather of modularity is. If you weren't there, or if you forgot, that's David Parnas. David Parnas wrote the paper called, or titled, On the Criteria in Decomposing into Modules, on decomposition into modules. So this white paper, or research paper, talks about the criteria to be used when you're splitting up things into modules. And that's the next learning goal as well, is what is that criterion? And it's decision deferment. So the most important thing to keep in mind is when I split things up, into smaller modules, then what determines what the contract is? What determines what the interface looks like between the modules? What it should be is, what do I think is going to change? Like, what are the features that I want to implement within the module, and I'm going to expose no information about the implementation, or at least I'm going to be very judicious or deliberate in what I do expose and what I don't expose, Because the things that I expect to change, I want them to remain flexible. I want to be able to change them in the future. So that's the idea of decision deferment. And then we ended last time with a couple of examples about using or looking at design principles like solid, like clean architecture, like hexagonal architecture, and how they all can be viewed in terms of modularity. Like if you start thinking about modularity while coding, you'll see that that's how almost any design principle is built up. It's about reducing complexity, making things smaller and simpler and easier to understand, isolating them from each other, isolating the building blocks from each other so that when change occurs, it doesn't impact too many pieces at once. And we also talked about a couple of the code smells. Shotgun surgery is the name of a code smell, where you're trying to implement a feature, but you have to change a whole bunch of classes at once. Or divergent change, which is the same thing, but except it deals with classes, like a single change in a class. If you have to update many methods, then those methods are too related. You're making a cascading change, which is an indication that you weren't able to defer the decision, or you weren't able to absorb the change. All right, so there's a tiny bit of noise in the microphone. I can try to fix that. That might make it slightly better. So, what are we talking about this time? So the learning goals are all oriented around decision deferment. So I want to show a couple of practical examples. I want everybody to go away with some idea of, hey, all this stuff you've been talking about, the abstract ideas around decision deferment and modularity, what does that look like in actual code? So I hope that by the end of this you'll have some idea of how I look at it, and I'm not saying that this is the only way of looking at it. It's a little bit subjective, I admit. Well, I mean, everything is going to be. And what I would like is to make this a little bit of an interactive session. So if you have questions, please ask them on the chat. Also, what I would like is that, and I heard this advice a while back, and I think it's a pretty good thing, because I too have a tendency to try and multitask when I'm in a video call, and I try to do multiple things at once, and then I'm like, ah, crap, I wasn't really following. I feel like I missed something important. So if you can, try to limit the multitasking that you're doing while you're viewing this. And please, if you have any questions, even if you think, well, he's going to answer that later, just ask it anyway. So let me see what's in the chat. It's about the sound, I think. Yes, there is some noise in the signal, because there is a bit of static around, and we're constantly trying to improve the technology and try to change the hardware and make it better. So this is definitely something we're aware of, and I hope that it will get better the next time. But as long as it's understandable, I'll just keep going. And if it's a really big problem, then we may address it. So please let me know if there's any huge variance in the quality of the sound. So today's learning goals. Modularity, right? Composable units with an interface contract. Well, the contract part, it's important that everybody has an idea of what do you mean contract, right? What constitutes the contract? What composes the contract? What is the contract made up of? So we'll cover that in some detail by looking at some Java code. The next learning goal for today is to understand how to grow a contract. First of all, you need to know what that means. What does it mean to grow a contract? Grow as in, yeah, what does grow mean in the term, in terms of code? You probably have some idea about what that means, but we'll try to make it concrete and try to give you some very hard definitions. So the next one, the third learning goal for today is to think about what types of questions and how to formulate questions when you're dealing with a real-life project that can help identify uncertainty and risk. And also those I'm trying to make as practical as possible. So next up, the last learning goal for today is to know to know that, so simply be aware of the fact that by choosing the contract, if you're doing it effectively, you're able to do it effectively, then you can absorb change. So you can write code in such a way that future change is less impactful. So I think this is the whole point. This is what we want to get out of modularity, right? This is why decision deferment is something that I think I need to spend two webinars talking about, because modularity is not just about simplicity, right? Simplicity is one of those two things that you want to achieve. You want to be able to make things easier to understand, make them simple, make them less interwoven, right? Because that's the root of the word simple and complex is to weave, is to braid things together. So simple means one fold, and complex means multiple folds, right? So it's folding coming together, and what we want to do is make things simple, yes, but we also want to absorb change. We also want to have changes in the future be easy. So we're going to be looking at an example application. As I said, I want to make this practical, and these are the requirements for this hypothetical application. So we're talking about an application which can do the following. Documents can be created and edited by users using this application. So it's document editing application. Second requirement is editing a document locks it for anyone else. So only one editor at a time. What does that mean, one editor at a time? It means, well, if you open it, nobody else can edit it until you've checked it back in. It's kind of like how Git works. The last requirement is it needs to be possible to unlock a document just in case. So in addition to be able to edit and then check it in and then it becomes unlocked for somebody else, we also want to have this feature where we can unlock a document just in case somebody forgot to check it in, or there's an emergency, or this person, for whatever reason, can't complete the action themselves. So what I'm trying to illustrate with these requirements, at least the wording of these requirements, is that this is maybe the level of detail that you might get them from a business person. Somebody who wants this application, but really hasn't thought through all of the details. So there's a lot of information missing here. So it's very limited. The information that we have here is very limited. But it's still, this is how real life projects work, right? So let's have a look at a simple, straightforward example of this. So I'll have to bring my editor into view, minimize the slides, and bring up IntelliJ. So zoom in a little bit. All right, can everybody read this clearly? I think everything's in view. If you can't, let me know in the chat. So this is a simple implementation. I had to think about how to make this simple, small, straightforward. What would code look like in a hypothetical situation where we're implementing this application? So I use some of the patterns that you will be familiar with. So there's a load for editing use case, the class that we're currently looking at. And there is a single method, load, which does the following. First of all, it uses a document repository to load the document by ID. There's two arguments to this method. So there's a user, the person performing the action, and a document ID. Then on the next line, we check to see if the editor of the current document, if their user ID, the ID of the editor, is equal to the user ID currently loading the document. If it's not the same, meaning the editor is not null, but it's somebody else, in that case, we'll throw an exception, document locked exception, which means that the current user is not allowed to perform this action. If that doesn't happen, if we don't throw the exception, then we set the editor to the current user and return the document. Any questions about this? Post them on the chat. you may already have some feelings about this. So I think most of you will know what this code is trying to achieve. And that should be pretty clear, but you may not agree with all of the implementation choices. But we'll get there. We'll see how this code will change over the following steps. So the next thing I want to talk about or ask, I want you to think about, with the code we just saw, what was the contract for the use case class? What was the contract? Again, we're talking about modules. The class in this case is the focus of our modular analysis. So what is the contract for the load for editing use case? If we go back and we have a look at the code, we're looking at a class. We see the class and we think, okay, so if we consider the class the module, which part is the outer layer with which the outside world or the other modules, the other parts of our application interface with this? Well, it's the public fields, right? If you're not a Java developer, then notice the word public, the keyword public in the code. Public fields are visible to the outside world, and other fields that are private or different scopes or different visibility are not immediately visible to everyone. So in this case, we're talking about clearly the public API of this module class, and we're asking what is the contract there. So I think most of you will have some idea in somewhat similar to this. So the contract for this class is, give me an ID and I'll give you a document. But if it's locked, I'll throw an exception. And now the question is, if you look at the code, is the exception an obvious part of the contract? So I'm going to fold the code and now look at it. You see the method signature, but there's no mention in the signature of the exception. And if you're a Java developer, you already know why that is. Because document exception in this case extends runtime exception. So runtime exceptions don't have to be mentioned in the method signature. You don't have to include them as part of your contract. If I were to change this to just a regular exception, you'll notice there's now an error telling me that, hey, there's an unhandled exception. Document locked exception isn't declared in the method. So if I fix this, I say add exception to the method signature, now it's added to the signature, and I can look at just the outer shape of this method, and now it's much more obvious that the exception is part of the contract. So the question was, is the exception an obvious part of the contract? I would say in the first state it wasn't. And we corrected a little bit by changing the runtime exception to a regular exception, just to make it clear that, hey, the person using this API, be aware that this thing may throw an exception. And I think this kind of illuminates why there is such a distinction between a runtime exception or errors, which are not checked, which means you don't have to declare them, and things that are checked. It's because you're being expressive in your code. You're telling the user of your code, the other programmer, that, hey, this exception is part of the contract. Be aware that you need to handle this. Because if it's unchecked, they won't get a message, and if they don't have a try-catch in place, then it just doesn't appear to them. There's no trigger to the other developer to consider what they should do in case of the exception. Now, follow-up question. What if the database is down? In our code example, there's now this document locked exception, but we're also making use of a document repository, which of course this is an example application and there's no real database connected to this. But generally speaking, database exceptions are runtime exceptions. If there's a connectivity problem, very often those things are runtime exceptions, like a socket exception or socket error. Those things won't be an obvious part of the contract, so you may not feel the need to catch them. And the reason why runtime exceptions and errors work this way is because very often those things cannot reasonably be recovered from. So what you really want to do, you want those exceptions to bubble up to one of the highest levels where they're caught and an error message is displayed for the user, because there's not really something we can do about it. Whereas the document locked exception, that's an application layer, that's a business exception. So the question is the database exception, are those types of distributed systems exceptions, the actual distributed errors, are they part of the contract? And I would say yes. They may not be an explicit part of the contract, but they are. You should still consider them and what to do in case they happen. So, conclusion, exceptions are part of the contract. Now let's have a think. I want you to think about, in the requirements that I just mentioned and the code that I showed you, was there anything that triggered your thought and you're thinking like, that's an assumption, or I wouldn't have thought about writing the code that way because I had a different interpretation of what was actually being asked? So here I have a couple of example questions, things that you could wonder if somebody just gave you those 3 bullet points in the beginning and said, these are the requirements. You could have thought, well, what if? Here's a couple of examples. So are there any other ways to lock a document? In this case, I just talked about editing, right? Just loading it for editing, but I didn't say anything else. Let me full screen this thing. Next, how and when is unlocking going to happen? Well, I didn't say anything about how or when it was unlocked. I just said it had to be locked if somebody else edited it, and there had to be some way, just in case, to unlock it. But how? What's the mechanism? When does it happen? Is there a scheduled job which does it at the end of every day, every business day? Is there a time limit? Does it expire? You know, nothing was specified about that. And how would that have influenced the code? Would you have written things any differently? Yeah, okay, that works. So next up is, are there any other entities that should support locking? We just talked about documents, but hey, we know how things work in projects, right? They say we want documents to be locked, but really what they're saying is, well, we just want things to be lockable, right? And if I'm editing an image, it also should be lockable, right? I said document, but what I really meant is any editable resource, right? If that's the case, then we probably would have written code slightly different if we knew that locking was going to be a generic mechanism. Whoa. Go back. So the last example I gave was, should editing always produce a lock? Or are there exceptions, right? Are there cases where you want to edit the document but not lock it, right? Is that a reasonable thing? I mean, asking the question, that is a good thing. I wouldn't say that the answer is likely yes, but you need to ask the question because you don't know until you've asked. So you may have seen a pattern in those questions, right? This is about the learning goal, about knowing how to ask those questions. The patterns are, we should start looking for absolutes, for what is the generic rule. And an easy way to do that is to use words like only, always, and any. Is it editable or lockable by any user? Can it be unlocked by any user? Does editing always lock it, right? So here's a way to use that using the exact requirements. The exact requirements that I showed a couple of slides ago, which are, there were just 3 bullet points that were very vague. I just inserted the words only, always. Sorry about that. My finger, I have heavy fingers. So I just inserted those words. If you go back and look at the other slide, you'll just see that the only difference is those words. I just inserted them. Documents can only be created and edited by users, meaning is there any other mechanism? Editing a document always locks it for anyone else. By using the word always, I'm trying to figure out, well, are there exceptions to this rule, right? And those things would have changed the way I had written the code. So if we go back and look at the code example, what if other use cases can also lock a document? So we're in the load for editing use case, and we have written this if statement, which checks whether it's locked and then does something, right? It throws the exception when the user isn't allowed to edit or to load the document. If another use case would be able to, or should be able to, lock a document, then this code doesn't really belong here, right? I mean, it's not really part of the responsibility of the load for editing use case. So think about decision deferment, right? If it seems likely that this is a generic thing that should be used from different use cases, then it's not really the use case's responsibility to implement this logic. It is a consumer of this functionality, but it's not the owner. So what we're really talking about here is the domain model pattern, which this may already have been something that came to mind when you saw the example in the first slide, or the first version of the code. You saw a bunch of logic there. You thought, that seems like it's logic that should belong in the domain model, and you'd be right. At least I would agree with you that it should. The domain model is a pattern which is pretty commonplace. I think if you use an ORM, like if you're a .NET developer, it would be Entity Framework, for example, or if it's Hibernate in Java, or SQLize in JavaScript. These ORMs very often will generate classes or support the use of classes to represent tables in the database. And there's this object relational mapping going on. But even though you have this domain model, doesn't necessarily mean that you're using the domain model correctly. It's there, it's generated by the ORM framework, but domain model means more than just a representation of a table in a database. The domain model is supposed to contain business logic. And what I've seen a lot of times is that even though we have a domain model, we end up creating a bunch of service objects which contain all the business logic, while the domain classes themselves are really just an aggregate of getters and setters, just a collection of fields. So it says so on the slide as well. The anemic model is a term that Martin Fowler used to describe this problem, where anemic means like blood anemia, means it's poor, there's no substance there. The domain model in this case is anemic. It contains only data and no behavior. So the way that would look, it's difficult to edit code while you have to look sideways. But see, this code really shouldn't be in the use case. So if I were to remove that, and I want my code to look like this, I'm going to say, I want it to be claimed by the user. I want to just have in the use case a single line saying claim by user, and it basically behaves the same way, except I'm not doing the logic myself. I'm asking the document to be claimed by the user. So I'm asking the document to do something, to perform some action. So if I create the method, and put the logic here, I need to edit it a little bit because obviously now the code is in a different location. So document really refers to this. Document refers to this. And throw new document exception because it's a checked exception. I have to also add it to the signature. And also I can say this to this. So now I've moved that little if statement and the statement underneath it to the domain object, the domain class, and I think I've also increased the readability slightly by looking. If you look back at the use case class, now there's fewer lines, so it's simpler, but I fixed the responsibility. I've moved the responsibility to where they belong, which is the document class. So I have to catch up a little bit because I've been ignoring the chat a little bit. Let me see if there's anything there. So the question in the chat is, in terms of a RESTful API, would the HTTP protocol itself be part of the contract? So again, it means it depends on what levels you're looking at. But yes, if we use RESTful as a design principle or as a design choice, then we are sort of saying we're giving meaning to all those status codes, right? To the methods as well. Post and put and delete all mean different things. So that is a contract for sure. That's absolutely part of the contract. But it's like I said in the last time, there's different levels of contract, right? There's the function, there's the class, there's the package, and then on top of that there's libraries and web services, which is a different level of contracts, but they certainly are. And with a RESTful service, we're building on top of these basic assumptions or these basic decisions about the meaning of things, the meaning of status codes, etc. And we're adding meaning like this path represents this resource, and this is how you address the individuals, and this is how you address the collection. Yeah. So the anemic model, we just fixed it, right? Now, let's go to the slide. So let's make old locks expire after a while. What does a while mean? So it's in quotes. So I'm trying to make the point that these things are usually not clear, not entirely clear. A decision needs to be made, right? And the word decision, well, that already tells you we want to defer this decision. We don't want to make the decision now necessarily. We want it to be able to change. And this is something that I talked about last time as well. Well, if we want it to change, I should make it configurable. I should probably make it a parameter, right? I have to be able to change it later. So what would that look like in terms of configurability, right? I could, for example, say, just add a expiration, right? I could add an expiration to the contract and say this is when the lock should expire. And then from this point of view, from this location in the code, I still don't know how it's going to happen. Is it a batch job? How does this expiration work? I don't know. I've put the responsibility on the other side of the interface, right? So the document knows, right? Or at least the document is my portal into the world of locking documents. I don't know, maybe there's a collaborator of the document that actually does the locking, right? I don't know from this point of view. All I know is it's now part of the contract. I want to be able to say this. Now, when you're changing code like this, when it's your own code base, this is not a problem. You can do this now, tomorrow, next week. Especially with type languages, you can refactor this code quite easily. It'll tell you with type checking, and the compiler will tell you when uses of claim by in other locations need to be updated to also pass this parameter, right? But imagine that this is a library that's on the public internet. People are using this, they're relying on it. Every addition to the list of parameters is a compilation error for your users. So upgrading for them means updating all their uses, right? And even though that doesn't seem like a big deal, you can imagine that this in the small can happen several hundred times with a big version update, and now all of a sudden people's code is broken, right? And now this is even worse when you're using a JavaScript where the compilation step doesn't exist, and you don't get this error message. Right? So I think in this case, well, TypeScript would help you for sure, but in this case, something I want to point out is, in terms of growing APIs, which is also something on today's agenda, is how would I grow this API? How would I make it so that this addition of this extra parameter doesn't in fact break anybody else? So I'm going to show you, I'm going to check out, because I prepared, I'm going to check out the other version of the code. All right, so now the things that I talked about before, the configurability of the expiration date, as well as the fact that the parameter list changed, I was thinking, like, how would a change like this look if it didn't break the users, if it didn't break the clients? So notice that the lock expiration in days is coming from a config object, which represents something like environment variables or properties, file, doesn't really matter. And then the call to document is no longer claim by, but just claim. Because I've thought about it, I'm thinking, like, if a locking is a generic thing, well, then it might not just be claimed by a user, it might be claimed by, I don't know, like a different entity type, right? And now I'm not passing two things, a user and an expiration date, I'm just passing a lock request, right? In this case, the use case class knows how to construct a lock request, but that isn't necessarily the case. It doesn't have to be the case that a lock request is constructed here. It might come from a factory object or some other mechanism for constructing it, so that knowledge doesn't necessarily have to live here. And if we go and have a look at the implementation, so inside the document, I've kept the getEditor method, because now the lock is the class that actually has the user stored inside of it. So editor now can be fetched from the lock, but I had to remove the set editor. The set editor no longer made sense, because the way that you set an editor is by claiming. So I had to remove a public method from a class. Again, I had to break the API in order to do this. Anybody using set editor in the past would have gotten a compilation error. So claim now takes a lock request, and I extracted the logic which checks the editor into a method called isClaimed by someone else. So if claimed by someone else, lock request get user is the one that I'm checking against, then throw the document lock exception, and otherwise I create a new lock. And look at this, the constructor of the lock takes the stuff that was in the lock request and puts that exact same stuff in the lock. Now you may wonder, why do this? Why not just have lock request be lock? Just say claim and pass the lock. Why would I do such a thing? Well, decision deferment, of course. That's the whole topic of this talk. I think in this case, if I were to take those two things and made them the same, I'm basically saying that the way in which I claim something, I pass the lock, I'm the one defining the lock, as in the client that is requesting the lock determines the lock and all its properties and all the fields and all the things. And then what does claim do? Claim just takes the lock, stores it, that's it. But those two things aren't the same thing, right? I mean, in this case, the lock expiration and the user are both fields, but, well, let's have a look at the lock. The lock also keeps track of the creation time. The lock, in its constructor, even though it receives those two things, initiates or instantiates the current timestamp, stores it as a field. So it wouldn't make sense if the use case class is determining the creation time, right? So it wouldn't make sense. It's really something that is the responsibility of the person doing the locking, right? Which in this case we decided that makes sense for the document to be responsible for that. So lock and lock request are not the same thing. And making them separate things has reserved a space, it has created a class to which I can add other things. So even though initially the difference between lock and lock request is minimal, that doesn't mean it's going to stay that way, right? It doesn't mean that that a lock request and a lock in the future will always mutate together, will always change together. An addition to the first will mean an addition to the next. So by splitting those two up, I'm enabling a future change, which means changing the definition of a lock separately from the definition of a lock request. So the questions, what needs to change and what else could change, is a moment to reflect on what things would have been different or would have been useful to have done in the first version to enable the expiration of the locking, right? So I needed to track the date and time of the lock, so I had to add that, right? I had to add some place to store it. And the way we had our code written in the beginning was that the document had a field called editor. And when something was locked, it just meant that the editor field was set. And that's kind of weird, because in the requirements, we're talking about locking, right? But in the code, I don't see, other than the exception in the first version, I didn't see the term locked anywhere. So that was also kind of odd. And I think if you know me, then you know that I'm a big fan of domain-driven design and the ubiquitous language, which also says that if the business is talking in certain terms, like, oh, I'm going to lock this document when somebody edits it, then we as developers should also adopt that language, or at least make sure that we in the business speak the same language. So it may not be the original business language, nor will it be the technical language of developers. It will be some compromise, but it will be the same. If the code and the domain language don't agree, well, why? Yeah, it's pointless. Like, why would you want that? Why would you have to translate somebody else's speech into your own mental model in order to understand the code? Wouldn't it be nice if everybody just agreed on the definition of words? So if I added the creation time of the lock and the expiration time of the lock to the document entity, that would have been weird, because it doesn't really belong there, does it? I mean, especially if we're thinking, remember we said maybe documents aren't the only lockable thing. Maybe other resources also should be lockable. If that were the case, again, decision deferment, if this change does happen in the future, I might have to copy paste all the lock related fields and duplicate them from the document class to the other class, which is also lockable. And now all of a sudden I have duplication. And yes, because I own this code, hypothetically, this is a single team is responsible for that, I can refactor that. But it's a pain to do it later, especially if those things are related to database tables. If those entities, their shape is actually a representation of a database table, then that refactor isn't just an in-code thing. I need to write a schema migration. And I need to migrate not just the schema, I need to migrate the data. I need to take those fields, put them in a lock table, and just by introducing this change, which I could have predicted, I now have to do a schema migration and a data migration. And those two things I definitely want to avoid. If I want to avoid cascading changes in code only, I definitely want to avoid cascading changes that hit more than just a single process. They also hit the database, which is a continuous thing. Like the schema doesn't change independently of the data has to follow. So if I were to add those things to the document, they may also become a magnet for other unrelated functionality. And you have to think terms like single responsibility principle, the S in Solid. It's doing more than just being a document, right? It's too much, it's a magnet. Like other lock-related stuff would start to add on, and it start to become this giant beast, right? So by naming the beast, I would say, hey, lock is a term in the business language, in the domain language. It should probably be its own thing in the code as well. And that all of a sudden now gives a home, a habitat for lock-related things to be added in later, which they may not exist initially. They may not be needed right away, but at least it'll reserve this spot, not just in the code, but also because they're entities, they'll also reserve a spot in the database model. Shotgun surgery, same thing, like if changes hit more than one class, that's a bad thing. So probably there should have been a lock entity from the start, which we just said. And normalization enables future change. So this is, if you're familiar with database normal forms or normal forms, I think it's, I forget the names, the Boy Cobb, or I'm not sure what who the guys are that came up with those, that define the normal forms, but they're defined as NF1, NF2, etc. And they all say something about how you should model your data in a relational database. And They say things like, hey, don't store more than one bit of data, one value in a single cell, right? If you just like comma separate things in a single cell, that's not normalized. That's actually, you're abusing the model. You're putting things not in their own place, but you're putting them together. Also, you're saying like another normal form rule is every row should be uniquely identifiable. So it also says that if two rows are identical, including the ID, there's some duplication in the rows, right? That's weird. So normal forms aren't just a database thing. They're also an object-oriented thing. Well, actually, they're just a programming thing, because in functional programming, this still applies, because you still have aggregates, you still have maps. So the things that belong together should go together, and you shouldn't mix and match, right? So this is, if you're a bit of a clean freak and you like a nice cleaned up room, this should be music to your ears. You should have a place for all your data. All your data should have its own home, and you shouldn't mix those things together. So last time in part 1, we talked about, or I talked about, I was the only one doing the talking, I talked about that maybe this whole decision deferment thing is nonsense, right? Maybe by doing decision deferment, like just now I suggested, hey, introduce a lock class, because you never know, right? It might happen that you need to lock other things, and it might happen that the lock will need other properties, other fields will be added to the lock later, so just add it because you know you're going to need it. That know you're going to need it part is dangerous, because there's a lot of things that I could say, I know that's going to happen, but those things are assumptions, right? So last time I said maybe by enabling our code to absorb change in the future, we're adding unnecessary complexity, because what if those changes never happen, right? Then we've added all these extra classes. And I think that you should really seriously think about that, because if anything, developers have a tendency to over-engineer code, right? So, or at least some of the time. So that triggered me to look at Kent Beck's design rules, or simple design rules. And these rules were formulated by Kent Beck and popularized by Robert Martin, and they're in order. The rules are written in a hierarchy. The first rule means your code has to pass the test. It's rule number 1. Rule number 2 and 3 are actually considered to be equal when it comes to priority. One isn't necessarily more important than the other. So the next 2 rules kind of go together. The second rule of simple design is your code must reveal its intention. You, the developer, it has to reveal what you're trying to accomplish with the code. So again, when we talked about, hey, document.claim, what does document.claim mean, right? Well, it does reveal intent, but again, I'm saying use the language very consciously, because if you want a shared understanding with the product owner or business expert or business analyst, you need to use the same term. So when document.lock is something that speaks to a developer and a business person, the intent is not just the developers, it's actually just a business language. So it makes sense, it matters what words you use. The code must reveal its intent. No duplication. Fewest elements, remove anything that doesn't serve the 3 previous rules. So this is where simplicity comes in. After you've done the first 3, look at your code and say, am I using too many parts? Are there too many functions? Are there too many variables? Are there too many classes? Have I introduced unnecessary complexity? And then you remove it. So that last part is important. You have to kind of look at what we did and really think, did I make anything using too many parts? Right? Are there any parts that, like, should I not have introduced a lock request? I have to think about it. Again, those rules are in priority, so it doesn't mean that if I can do with fewer pieces, I should. I just make it as few classes, as few methods. I just need to think about it. Am I happy having both a lock and a lock request class? So, we're in the final stretch of the presentation. Let's see how long I've been talking. I've been talking for... Why doesn't it say? Okay, yeah, okay, so 50 minutes. I gotta speed up, sorry about that. What constitutes the contract? So we talked about the use case class, and what's obvious is that the type signature is part of the contract. What are the input parameters? How many parameters are there? And what is the return type? But also exceptions, right? We talked about that as well. What we didn't talk about, we did mention it last time, is thread safety. It's not in the method signature. Just looking at the public API doesn't tell you whether it's thread safe or not. You have to read the docs, read the Java doc. You have to read something outside of just the code to know this. And it's important. It matters. It matters a lot. And so, like, it's possible to get compile time checks for this, and I wish that we did have those. But the point is, that's part of the contract. As in, if that changes from one version to the next, let's say it went from thread safe to being not thread safe, that introduces the hardest bugs to catch. Now, this one isn't so obvious, but also part of the contract. So configurable properties and their default values. So if I look at the method signature, I might not be aware that it depends on an environment variable, or maybe on a properties file that's on disk. It might load that and depend on those properties, and the behavior might change. So even though I can't see and understand those things from just looking at the public interface, they're part of the contract. Because if I have a library and I upgrade to the next version, and the default values for the configurations change, my code might break, right? So those default values matter. And if you're a publisher of an API, be aware that those things are part of the contract. Other people will rely on those values, and if you change the default values, it'll change the contract. The actual mapping, so if again, the simple example, if I have a function which adds up two numbers, if all of a sudden in my new version it multiplies the numbers, I've broken the contract. So it's not just the interface, it's also the behavior, it's also the input and output. But it's, oh shit, yeah, I just want to say that the contract is really anything that was promised. And even if you don't think you're promising it, even if you think you're not saying that explicitly, if you're not saying it and other people are seeing the behavior, like for example thread safety, they might just assume that it's implicitly part of the contract. So you have to be very careful, and sometimes you may have to say in the documentation explicitly, this is not part of the contract. This may change in the future, right? You've seen that a lot in code, right? Code tells you that. Don't use this, or don't rely on it. Be aware, warning, it might change, right? Even if you don't promise anything, there is an implicit contract. We also talked about growing the API a little bit. Last time we also talked about the open-close principle, that there's two types of changes really. There's modification and there's extension. Well, extension should be safe. Adding things should be safe. Growing your API should be safe. Changing the existing API isn't safe. So here are a couple of examples of things that you can use to extend or grow your API. So extending the return type means my return type is now a subclass of the original one, or I'm just adding a field to it. If I'm adding things to the return type, shouldn't matter. You weren't using them before, now you get them, but you're still not using them. Doesn't break your use of my API. No longer using or relying on a parameter. You pass me this thing, but I no longer use it. That doesn't change the behavior, or at least I shouldn't change behavior necessarily, and it doesn't break your use of my API either. If I removed the parameter from the signature, then yes, that would be a breaking change. Adding an optional parameter or field to a parameter class, adding fields to an object that is a parameter, doesn't necessarily break it. It just means it should be optional, right? If I extend or I add things to the class that you pass to me in the next version of the API, then that doesn't necessarily mean that your API breaks, as long as I don't require that field to be set, right? Adding optional configuration with the default value, we talked about this. This is very similar to the parameters. Adding a method to a class, again, you didn't know it existed, so you couldn't have relied on it. Just adding the method doesn't break it. Now, going from a protected visibility in Java to public. It was invisible first, now it's visible. Again, because it was invisible, you couldn't rely on it. You could override it if it's your subclass. But public is a superset of protected, so it shouldn't break your API. The nice thing here is if you go the other direction, from public to protected or to private, the compiler will actually enforce this rule, right? It will tell you you're not, for example, if you subclass a class in, if you extend the class in Java and you go from from public to private, now people that you relied on the thing being visible now see, hey, but the subclass just made it invisible. That's not allowed. That's a violation of the open-close principle, and it's actually enforced by the compiler. Providing more and requiring less. This is kind of like the general rule. If I provide more or require less of you, this is an extension. It shouldn't break you. Breaking changes are basically all of these things in reverse. Changing the parameter list. Changing the return type completely to a completely unrelated class. Removing or renaming fields and methods. Renaming fields in methods doesn't necessarily change the functionality, because the parameter name doesn't really matter in Java. What matters is if I change the name of a field. So if I have a class and it used to be called editor and now it's called user, right? That change will break the use of the API. Again, if this is a single code base and I do rename field and it's a refactoring step using IntelliJ, it changes all over the place at the same, but it needs changing, that's the point. If this were a public API, then things are very different. So this thing about a public API mattering, and I should have probably said this at the beginning. Listen up, this is important. Even though I said that the growing of your API matters a lot more when you're publishing an API, a public API, so a web service API, or if you're the author of a library, because you don't want to break your users, and your users are remote to you. You don't know who all your users are. You don't know who all depends on your API, so you want to be conservative about breaking them. Even though that's true, these things also apply to your own code that only you use. Why does it matter? Because small numbers of these are okay to fix. It's easy to implement new features if every feature just requires a few refactoring things. But this, in a large code base, will impact you as well, even if it's all your code. If you need to fix all kinds of breaking changes all over, if you have to apply shotgun surgery to your own code, even though your compiler will help you, it still slows you down. So decision deferment, modularity, and growing your API, these are not just things that you care about when publishing APIs with public users, public APIs. It matters for your own private code as well. Let me see, let me read what's in the chat. Some people complaining about different language uses, so different terminology. Yes, it can be painful when a business doesn't speak the same language as the development team. Question: if we're writing code where the implied contract might change, doesn't that suggest that there is a problem in your implementation or requirement needs further clarification? Well, if the implied contract, if the contract isn't explicit or made explicit by the author, it's implicit, so it's still part of the contract whether they like it or not, unless they openly disclaim and clearly disclaim that and say, no, this is not part of the contract, even though it's implied by the compiler, by the code itself, by the behavior. This thing might change, and they warn you about that, then that's okay, that's fair game. But every author of an API should be aware that some things are implied. You may not realize that it's part of your API, but other people might still rely on it. For example, let's say I write an application and it reads from disk, right? And it reads in a specific order from this directory to this directory. And I never said that that's how it worked. It was just an implementation detail. But somebody just looked at the source code and saw, I do that. So I'm going to use the order of the directories to to kind of override certain configuration properties or whatever. And I'm going to rely on this part. Even though it's hidden behind the interface, it's not in the method signature, it's part of the behavior. But I never said it was part of the contract. Now, if I change that in the next implementation because I thought, nobody knows this, right? Who looked at the source code? Well, somebody did. Somebody looked at the source code and started relying on that specific implementation. These things happen. And yeah, there's no one way to fix that. All you can do is try to communicate as clearly as possible about what your code does and what is and isn't part of the contract. What do you do if the client changes the language that they use? So they're going to rename something, but it's everywhere in the code. I mean, well, yeah, that's a conversation, isn't it? Like, if you're doing DDD, hopefully you will have convinced everybody to say, well, I'm going to commit to this domain language, to the shared language, the ubiquitous language. They're going to commit to it. We're going to introduce this glossary on our wiki. We're going to define words. We're going to make sure that the terminology in the designs matches the terminology in the implementation, and also matches the terminology that we use day to day in email and on Slack, right? So that's a commitment. And if somebody says, well, I'm going to start using a different term, I mean, you have to kind of have that conversation about, like, we're either committed to having a shared understanding or we're not. And if it's very important and useful to change the term, then yeah, I guess we should. Again, to the point that it doesn't break anybody else, right? Because if you're in a team and the terminology is part of your API, so the keywords in your public API, which other teams might rely on, is influenced by this change in language, then you have to kind of have a grace period. You have to have like a deprecated feature, version your API. Those things are ways to deal with that. Can we really source code is not part of the contract, even implied? Surely the only contract is what we choose to make public. Well, again, like, people can still read the things in your implementation. They can still figure out the behavior internally, right? So even though it's not, you never promised anything, people still rely on the implicit contract, right? They can examine, reverse engineer the behavior and say, okay, apparently this is how it behaves, right? I'm not saying that's a good thing. I say it happens, right? It happens that people start to rely on things that you never meant to be public. I'm not saying it's a good thing, again, it happens. Code. So one tip I gave is normalize. Use normal forms, not just in databases, but in code. Give everything, every entity, its own class, so that it can become a home for future changes, not so that you have to define a class and extract a class in the future. The more you have to do that, the more annoying, the more breakage. So try to normalize early. Oops. Parameter objects, the lock request. I had 2 parameters, and every addition or change to the parameter list breaks the API. So why not just put a parameter object there if I suspect that those things will keep changing? Like, what does the definition of a lock request mean? Like, what might happen to it? Might things be added to it later? If I suspect that that's the case, a lock request or a parameter object means that I can add things to it later, make them optional, and people's use of my API doesn't break. Again, optional parameters is a way to make things changeable. So if they're configurable, just like a parameter, if I define a parameter, it means different values are possible for that parameter. That means that that the user can define the values. The same is true for configuration. But when parameters and configuration are optional, you have to be careful about that, because you might want to change those things, because again, they're part of the contract. So if you want to change that in the future, people will consider that a breaking change. So those are ways that you can make your code flexible to enable future change. To support this decision deferment way of looking at things is to define classes for things where you expect to change behavior. And when you're looking at single methods, just make sure that the signature, the parts of the contract, that you're aware of all of them, thread safety, exceptions, etc. So I hope that this is all pretty clear about decision deferment, how you can ask questions, to identify a risk and uncertainty, and use these practical tips like normal forms, normalization, data normalization, but just model normalization in general, and parameter objects, and how you can think of things to grow your API, like adding fields to return types shouldn't break anything. Adding optional input is also not a breaking change. Adding methods isn't a breaking change. Those are things you can always do without cascading all over the place, not just when you're publishing a public API, but also inside your own code base. You want to limit cascading changes as much as possible, and these hopefully are some practical tips. Let me have a look at the chat. Right, so there's, yeah, that's true. What Tony is saying, that there's a tendency, I guess, to just look at the source. If you want to know how something works, just look at the source code. And our editors make it really easy to do that. You just jump to implementation, jump to definition, and your editor will jump to the source code of the library that you're consuming and show you how it actually works under the hood. And this is very, very useful for multiple reasons. Like, you get to learn how other developers write code, and you might learn techniques from them by just looking at their code. That's how I learned a lot when early on in my career, is just look at the Spring sources. I found it very educational. But because you understand how it works, now you're like, oh, I see the matrix. Now I can do this, and it gives you a lot of power, right? And as long as those parts were meant to be part of the contract, so the library authors made those things public deliberately, then that should be usually okay until a major version update, and then things change a lot. But sometimes people aren't so judicious. Sometimes people make classes and methods more visible than they should be, or they need to be, in which case they may later regret it, they want to change it, and now their clients need to upgrade or need to change their usage as well. Yeah, so you can even change the source code of the library that you're using. Yeah, that's nice of JavaScript. Breakpoints, yeah, that's possible in Java too. You can just update the add breakpoints to the implementation of the library that you're using, and just debug it and figure out how it works internally. So these are all things that as developers we do all the time, right? But we're also maybe not so aware of future changes, things that happen, library versions that need to update. And if we start relying too deeply on our libraries, then that's a problem. And also we have to evaluate the choice of libraries based on these things. Do they respect backwards compatibility? Is this a library that's written by two guys in Denmark in a basement somewhere, and they never intended it to become popular, and you're thinking like, this solves my problem perfectly, npm install, right? That if you do that too readily, maybe they don't respect backwards compatibility, and they'll be very cavalier or about breaking you. So that you have to be very deliberate about that. So I went on for quite some time. Sorry if I went too slow. I hope it was useful. If you guys have questions that I didn't get around to, or that maybe I didn't read them, or you can come up with them later, please, you can message me. You can @ me on Twitter. I don't really use Twitter that much anymore, but you can just send me messages on Slack or on LinkedIn if you saw it there. And I hope that modularity is something that you will use, especially decision deferment, as a way to look at code now. It's just think about future change, and can I enable that change later? Normalization, growing an API, all those things, I want them to become common use in our developer vocabulary. So thanks again, and have a nice day.